Chapter 6 Application of Derivatives Exercise 6.2 Question number 6 Find the intervals in which the following functions are strictly increasing or decreasing. A. X square plus 2x minus 5. B. 10 minus 6x minus 2x square. C. Minus 2x cube minus 9x square minus 12x plus 1. D. 6 minus 9x minus x square. E. X plus 1 whole cube, x minus 3 whole cube. So A, let us consider f of x is equal to x square plus 2x minus 5. Now f of x is a polynomial function, so we can write f of x is continuous and differentiable in our. So next step we will be finding what is f dash of x, that is d by dx of f of x, that is x square plus 2x minus 5, and d by dx of x square, that is 2x, d by dx of 2x, that is 2, d by dx of 5 0. So we have 2x plus 2 or 2 into x plus 1. So we have got what is f dash of x. Now we will be considering f dash of x is equal to 0. We have 2x plus 1 is equal to 0 or x is equal to minus 1. Now we have got x is equal to minus 1. Now we will be splitting R, divides R into disjoint intervals. For that we will be drawing a line segment with a minus infinity to plus infinity, and we will be marking a point minus 1 on the line segment. So we have the interval, that is minus infinity to minus 1 and minus 1 to infinity. So when x belongs to the interval, that is minus infinity to minus 1, we have f dash of x. What is f dash of x? That is 2 into x plus 1, right? So f dash of x is equal to 2 into x plus 1. 2 is a positive quantity, and if you are applying a value for x in between minus infinity to minus 1, we will having s plus 1 is a negative quantity. So we can write f dash of x is equal to positive into negative, that is negative. So we can write f of x is strictly decreasing in minus infinity minus 1 when x is less than minus 1. When x belongs to the minus 1 to infinity interval, we have f dash of x, that is equal to 2 into x plus 1, that is 2 is a positive quantity, x plus 1. Again we are applying a quantity in between minus 1 to infinity, it is positive. So positive into positive, f dash of x is a positive quantity. So we can write f of x is strictly increasing in between the interval minus 1 to infinity when x is greater than minus 1. Now B part of the question, that is 10 minus 6x minus 2x square. So let us consider f of x is equal to 10 minus 6x minus 2x square. So f of x is a polynomial function. We can say that f of x is continuous and differentiable in R. Now we will be considering what is f dash of x, that is d by dx of 10 minus 6x minus 2x square. What is d by dx of 10? That is 0. D by dx of 6 minus 6x, that is minus 6. D by dx of minus 2x square, that is minus 2 into 2x. Or we can write f dash of x is equal to minus 6 minus 4x, or minus 2 is taken outside. So minus 2 into 3 plus 2x, that is f dash of x. Now if you are considering when f dash of x is equal to 0, we have the equation, that is minus 2 into 3 plus 2x is equal to 0, or 3 plus 2x is equal to 0. X can be written as minus 3 by 2. So x is equal to minus 3 by 2, which divides R into the disjoint intervals, so that we are drawing a line segment from minus infinity to infinity. So minus 3 by 2 is marked in between. So we have when x belongs to the first interval, that is minus infinity to minus 3 by 2, we can write f dash of x is equal to minus 2 into 3 plus 2x, right? Minus 2 is a negative. So 3 plus 2x, we are applying a value for in between minus infinity to minus 3 by 2, that is also negative quantity. So negative into negative, that is positive. So f dash of x is positive. So we can write f of x is strictly increasing in between the interval minus infinity to minus 3 by 2. Similarly, so here the x is greater than minus 3 by 2. So when x belongs to the next interval, that is minus 3 by 2 to plus infinity, we have the f dash of x, that is minus 2 into 3 plus 2x. Minus 2 is negative, 3 plus 2x. Again we are applying in between minus 3 by 2 to plus infinity. It will be a positive quantity. So negative into positive, that is negative. So we can write f of x is strictly decreasing in the interval minus 3 by 2 to infinity. So we can write x is less than minus 3 by 2. C part of the question, that is minus 2x cube minus 9x square minus 12x plus 1. So let us consider f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. So we have f of x is continuous and differentiable in R because f of x is a polynomial function. So f dash of x, that is d by dx of minus 2x cube minus 9x square minus 12x plus 1. D by dx of minus 2x cube, that is minus 2 into 3x square. D by dx of 9x square, that is minus 9 into 2x. D by dx of minus 12x, that is 12. D by dx of 1, 0. So we have minus 6x square minus 18x minus 12. Or 6 is taken outside, minus 6 is taken outside. So minus into x square plus 3x plus 2. X square plus 3x plus 2 can be written as minus 6 into x plus 2 into x plus 1. So when the f dash of x is equal to 0, we can write minus 6 into x plus 2 into x plus 1 is equal to 0. X plus 2 or into x plus 1 equal to 0. So x can be either minus 2 or minus 1. We have x is equal to minus 2 or minus 1. So we are dividing r or splitting r into the disjoint intervals, so that we are drawing a line segment from minus infinity to plus infinity. We are marking 2 points, that is minus 2 and minus 1 on the line segment. So we have the first interval, that is minus infinity to minus 2, second interval, that is minus 2 to minus 1, and the third interval, that is minus 1 to infinity. So we can write when x belongs to the first interval, that is minus infinity to minus 2, we have the equation for f dash of x, that is minus 6 into x plus 2 into x plus 1. Minus 6 is a negative quantity when we are applying any value for in between minus infinity to minus 2 for x. We have the x plus 2 as a negative quantity and x plus 1 as also a negative quantity. So negative into negative, positive, positive into negative, negative. So we can write f dash of x is a negative quantity. So f of x is strictly decreasing in the interval minus infinity to minus 2. Now in the next interval, that is minus 2 to minus 1. When x belongs to the interval minus 2 to minus 1, we can write f dash of x, the equation for f dash of x, that is minus 6 into x plus 2 into x plus 1. Again, we are applying the value for x in between minus 2 to minus 1. We have 6 as a minus 6 as a negative quantity, x plus 2 becomes positive, and x plus 1 is again negative quantity. So we have f dash of x negative into positive, that is negative into negative, positive. So f dash of x is a positive quantity, so we can write x of x is strictly increasing in the interval minus 2 to minus 1. In the third interval, that is when x belongs to the interval minus 1 to infinity, that is x belongs to minus 1 to infinity, we have f dash of x, that is minus 6 into x plus 2 into x plus 1. Again, we are applying the value for x in between minus 1 to infinity. We have 6 as a negative quantity, minus 6 as a negative quantity, x plus 2 becomes positive quantity, x plus 1 becomes positive quantity. So we have total f dash of x negative quantity. So f of x is strictly decreasing from the interval minus 1 to infinity. So we in conclusion we have f of x strictly increasing in minus 2 less than x less than minus 1 and strictly decreasing in the interval, that is x when x is, in the first case, that is when x is less than minus 2, and the second case, that is when x is greater than minus 1.